Okay, we go back to this example. Okay, so we have this. I'm showing you the manual computation. Okay, in case lang you have time to check or to verify na same lang yung results sa software and then yung sa manual computation. Okay, so we have this, okay, ANOVA table here. So take note that there is an added variation. This is the block as the source of variation. Before, for CRD, we only have treatment, error, and total. Now we have this additional variation. Okay, so we have this row. Okay. And then I'm using now the R, okay, R software to come up with this result. Okay, as you can see, significant, highly significant yung treatment. But for the block, which is the age, okay, it's not significant. Okay. Now, okay, so this is just a quick review. So we have to state our HO here, no differences among the means. HA, at least one diet program has a different mean. And then test statistic, we use the F. Okay, assuming na, ayun nga, na-satisfy yung assumptions. And then decision rule, okay, we have this. And then recall that our p-value using the software, we have 0.004, this one here. So we can now compare this to the alpha, 0.05. Then, since it's less than alpha, we can now reject the HO. Then the conclusion, we have sufficient evidence to say that at least one diet program has a different weight loss mean, or the diet program is effective. Okay? Effective siya kasi, again, ina-reject natin yung HO because of the p-value na less than 0.05. Okay? Now, since, okay, before, in the previous discussion, yung about sa if in case significant yung treatments or yung pag-test ng treatments, if, okay, there is this significant test, or we found out that there is this difference in the means, okay, we can now proceed to pairwise comparison. So for the pairwise comparison, using Tukey's HSD, this is automatic when use the R commander sa R software. Okay, so you can use this, and then you can check the p-value. So the p-value here for the B and A, so pair B and A has this 0.002, meaning to say this B and A differs in terms of their means, right? Okay, so this diet program A and diet program B differs. And then another pair that differs, ano pa? We have the C and B. Okay, so this B again and the C, and then another is the B and the D. So therefore, in short, we have this diet program B that differs from the rest. I hope you agree with me. We can go back to the raw data. I'm sorry. If we go back, at least we can relate now bakit naging ganon yung result. So balikan natin yung raw data. Okay, B, where's the diet program B? Here. As you can see, siya yung pinakamababa na values for each block. So siya talaga yung naiiba, no? Compared to the rest of the diet programs. Okay, so at least now we understand. Now we can relate the result to the data that we have, or we can even get the mean, the descriptive statistics. Where are we now? Okay, so we're done with this. Okay, we have tested for the treatment means, and then we have tested for this pairwise comparison, and then now for the blocks. Okay. Now the HO, okay, the blocking strategy is not effective, so this is denoted by rho sub j equal to 0 versus the HA, rho sub j not equal to 0, or the blocking strategy is effective. Okay, the test statistic, again, we use this ratio wherein the numerator is now for the block, so MSR. Then decision rule, as usual, we reject HO if the F is greater than the F tab or the p-value is less than alpha. Now, we go back to the ANOVA result. Oh, see that 0.1322. Okay, this one here. The ANOVA result 0.1322 is actually now compared to alpha 0.05, and then, okay, that's greater than 0.05, that value, 0.1. So we cannot reject the HO. Okay, and then our conclusion now, okay, the blocking strategy is not effective. Okay, or there is no sufficient evidence to say that at least one age group has a different mean. Okay, so the blocks are just of equal means. Okay, I'll just show you. I'm just showing you this code. If you are using the R, okay, software. So this is very helpful, especially in getting the result for these two keys. For the for checking for the additivity assumption. Okay.